Hello, my name is Jaliesa, and today for my presentation I will be discussing the end of everything. Modern cosmology is the study of the nature and evolution of the cosmos itself. It has allowed physicists to explain the history of the universe from the very first tiny fraction of a second until today. We now have the tools to extend our knowledge into the distant future and speculate about the ultimate fate of all reality. But what's next? I will discuss 4 potential universe-ending theories today, describing what those theories might look like. The theories to be discussed are the Big Crunch, heat death, the Big Rip, and vacuum decay. Optical, radio, X-ray, and gamma-ray telescopes on mountaintops and in space all extend our view to the edge of the universe. But what that really means is that they extend our sight into the past. Telescope users have a window into time. Light travels at a finite speed, so everything comes to us within its own time delay. So, we see the sun not as it is now, but as it was 8 minutes ago. We can look even farther back and see matter swirling into supermassive black holes in a universe less than 500 million years old, when starlight had only just begun to penetrate the darkness between galaxies. Techniques for looking backwards through the eons can actually help us peer into the future too. The equations for physics run forward as well as back, so we begin to see a picture of what the far future evolution of the universe will look like. It's actually more than one picture and painted by cosmologists with different conflicting theories. The 4 theories discussed today is the current thinking, all grouped into a few different scenarios in which some are more plausible than others. The first of 4 theories I will discuss today is the Big Crunch. Andromeda is a galaxy with 1 trillion stars whizzing around a supermassive black hole and the Milky Way's nearest neighbor. Right now, it's heading this way. The distance between Earth and Andromeda is about 2.5 million light years. However, it is closing that distance at about 110 kilometers per second on a crash course with our galaxy. In about 4 billion years, the galaxies will start to merge into one. Galaxies do regularly collide, but only really powerful telescopes such as the Hubble telescope can detect these collisions. These galactic mergers are becoming more and more rare because in the universe, the giant stuff like galaxies is drifting farther apart from one another. The galaxies are drifting apart because the universe is expanding, and that expansion all started with the Big Bang. The Big Bang is pushing the space between each neighboring galaxy slightly bigger, and as a result, the ends of the universe have gotten farther apart because of the collective space between all these small expansions happening within its limits. The question is, will the initial push from the Big Bang eventually fizzle out? Gravity attracts everything to itself, so it's inevitable that Andromeda and the Milky Way will one day collide. But the further apart 2 objects are, the gravitational attraction between them does get weaker, but it never reaches 0. It seems like the gravity of everything in the universe should eventually pull it all back in. Much like throwing a ball up into the air, it eventually comes back down. So what happens if the expansion stops and goes in reverse? In a collapsing universe, the space between galaxies would get smaller and smaller. Collisions would become more frequent, and stars and planets would be flung out of orbit. In this scenario, black holes ignite and merge, becoming even more massive, matter whirling into these black holes and superheated by friction so hot that it shoots out jets of radiation, scorching anything in its path. During these galactic crashes, some new stars will be born, and new planets even. Some of them might even have the time to develop life. But eventually, in time, these too will be destroyed by fire. As the universe collapses, all of the energy that's ever been emitted by every star or drawn into any black hole will be squished into a smaller space and squeezed into higher energy wavelengths. The concentration radiation will become so intense that the temperature of space will rise until nuclear explosions rip stars, planets apart, leaving only a space full of hot plasma. At this point, the universe resembles the early moments after the Big Bang. And with this, the universe ends in flames. But what if that crunch never happens? The next theory explored is the heat death. When you throw a ball into the air, it slows down and falls back down to you. In the heat death, it's like what would happen if you threw a ball into the air and it reached the escape rate and just kept going faster in the same direction forever. The bigger our universe gets, the faster it's expanding. In the early days of the universe, things were close together and the gravitational attraction slowed the outward push of the expansion from the Big Bang, and the expansion was slowing down. But in 1998, scientists discovered about 5 billion years ago that the expansion of the universe started speeding up, and it still is. In the universe, 68% of empty space is pushing outward in all directions, and this is called dark energy. The more empty space there is, the more dark energy and the more it pushes. Dark energy might be a source of energy that never runs out and that we find everywhere that there's empty space. This is something called a cosmological constant. As the universe expands, it makes more empty space, which means more dark energy, and the expansion gets faster and faster. Forces like gravity and electromagnetism are still strong enough to keep our molecules together, keep your feet on the ground, keep our planet orbiting the sun, and stop our galaxy from falling apart. But the vast spaces between galaxies are dominated by dark energy. The universe is already expanding faster than the speed of light, meaning that light emitted from galaxies beyond this point will always be moving away from us and will never reach Earth. As that expansion speeds up, closer and closer galaxies will be outrun and they'll disappear from our view. 100 billion years from now, the Milky Way will dim and eventually fade to black, and even black holes will evaporate. There will be no fuel for new stars, just vast empty space, filled only with dark energy expanding forever. This would be a very slow death, lasting hundreds of billions of years. This leads us to the next theory, the Big Rip. In this theory, dark energy is much more powerful than anticipated. Phantom dark energy would not only expand the space between things, but expand things themselves. In our universe today, fundamental forces are enough to hold things together, even as dark energy expands the universe as a whole. But phantom energy would be strong enough to overcome all of those other forces. It wouldn't just push galaxies apart, it would push stars away from galaxies, planets away from stars, and tear planets apart. Eventually, atoms, molecules, and particles would rip apart as phantom dark energy becomes stronger than the electromagnetic forces that hold them together. In the final moments, the very fabric of space would be torn apart in a big rip. The final theory that will be discussed is vacuum decay. This scenario might be less far off, and it could happen at any time. It could even be happening right now. But it destroys everything so fast that you wouldn't even feel it. The Higgs field is a sort of energy field that permeates all of space. It surrounds us and penetrates us, and it binds the galaxy together. The Higgs field sets the rules for physics on the scale of particles, like what particles exist, how they interact with each other, and what their masses are. Atoms and molecules, trees, people, and planets for that matter are only able to hold themselves together and exist because the Higgs field has a particular value. If that value were slightly different, it would scramble everything. The Higgs field is pretty stable. It's settled down here at a low energy, but there is a small chance that an ultra-high energy explosion like the evaporation of a black hole or a quantum event could actually kick the Higgs field into some lower value. This would create a sort of bubble in the Higgs field, a new kind of space with different rules. This bubble would zip through the universe at the speed of light, ripping particles apart and swallowing everything in the bubble. And if it hit you, you'd be gone before your brain even knew anything happened. Once this bubble has destroyed everything, the space inside it collapses into a black hole. And with that, the universe would end quickly and in darkness. Thank you so much for listening to my presentation.